This recording is to help you with lesson 3.01, exponential functions and their graphs. Right, the first thing we're going to do is we're going to start by graphing an exponential function by hand. So in order to graph an exponential function by hand, you need to create a table. And your table can be of any x values that you want. And then you have to figure out what the y values will be. And then once you have your set of points, you can graph them and kind of just connect the dots to come up with your graph. So you can choose any x value points that you want. In 19, they chose -1, 0, 1, 2, and 3. When we plug -1 in, we get 5 to the -3rd, which is the same thing as saying 1 over 125. Because remember, if you have a negative exponent, in order to make that exponent positive, you need to change the location. So it's originally in the numerator. Let's put the 5/3 in the denominator. 5/3 to the third power is 125, so that's how we get 1 over 125. And you can continue the process for the rest of those values there. Notice when x is 2, you get 5 to the 0 power. Anything to the 0 power is always 1. Okay, so don't forget that rule. Anything to the 0 power is always 1. All right, we connected our dots to get a graph that looks something like this. Notice that the asymptote is y equals 0. And you have an intercept at 0 and 1/25, because if I were to plug 0 in for x, what is my output? Well, 1 over 25. And my graph is increasing, and you can tell that by the y values in your table as well. All right, next, we can actually graph this first. So when I graph this function, I get this right here, and it appears that the asymptote is y equals 0. Again, it gets closer and closer to the x-axis, but never touches it. So that means I have a horizontal asymptote at y equaling 0. All right, for the next one, we need to use a graphing utility to complete our table, and then we're going to compare our graphs. So notice that f of x is referring to the function 3 to the x power, and g of x is referring to the function 4 to the x power. So 3 to the -1, I would get 1/3. 4 to the -1, I get 1/4. So that's how we can start our tables off, and we can fill them in from here. And I'm just trying to compare here. It looks like they use different values almost for these. Let's change these values here so they actually match up with our answer. Let's make them -2, -1, 0, 1, and 2. That's kind of crazy. So I'm just going to move these two responses over a column. 3 to the -2 power is 1/9, and 4 to the -2 power is 1/16. Now we can continue on and fill our tables in, and we can graph them. Now, it's a little difficult to see because the graphs are kind of smushed together, and I'm going to try to highlight to see if it makes a difference. All right, this line right here in pink refers to y equals 3 to the x power. Okay, so that's the first one. And the second one, in orange, is right there. That refers to y equals 4 to the x power, which is right there. Okay. Now, part A asks, when is 4 to the x less than 3 to the x power? So 4 to the x is less than 3 to the x. So the orange is under the pink from x is less than 0. My highlighting is not the greatest, but orange is under the pink when x is less than 0. And orange is over the pink, which is greater than, when x is greater than 0. So here the orange is now on top. Notice you do not have the equal bar in either of these cases. The reason we do not include the equal bar or equal sign there is because at x equaling 0, they are actually the exact same value. So one is not greater than the other. They're equal to each other at that point. So that is why we do not include the equal sign underneath our inequality values there. All right, and the last question is, which functions are exponential? In order to have an exponential function, you must have a variable in your exponent. Notice that a does not have a variable in its exponent. It is just 1. That is not an exponential function. Neither is b for the same reason. 2 is not a variable. It's a constant there. So that is not an exponential function. C, yes, you do have an exponential function. And D is also 1 as well, because you do have a variable in your exponent. And it doesn't matter if it's positive or negative, you still have an exponential function there.